Hi there, general math students. Now, one of the most interesting, most intriguing problems in mathematics continues to be the travelling salesman problem. Now, this was a networks problem that people have tried to solve over a long period of time. But unlike Euler's theorem, where we have some proof about planar connected networks, and Euler's circuits or Eulerian circuits and Eulerian paths, where we have hard and fast rules about number of odd vertices and all having even vertices, all that sort of stuff. There are no hard and fast rules with the travelling salesman problem. This has never been solved, and so there's no proof involved in these types of problems. In fact, they really just involve trial and error. But if someone was to solve this problem and come up with a proof, they would be, well, very famous, because, at the very least, because this is a classic optimization sort of situation. Particularly, you can imagine logistics companies are doing this sort of thing all the time, where they're making deliveries to different locations and they want to travel the shortest distance possible while doing that. And that's what this problem really involves. So a salesman leaves his home at A, that's just labelled home, there's no A there, and must visit these towns B, C and D, and then go back home again. So what type of path should the salesman follow? Well, this path involves going to each vertex once and returning where you start. So rather than a path, it's actually a circuit, and because we're going to each vertex, not each edge, it's a Hamiltonian circuit. All vertices, that's the reason why. All vertices must be visited. Okay. So, like I said, trial and error here. We've really just got to find a few Hamiltonian circuits and see which one is the shortest, and hopefully within that list that we do have the shortest one. It can be difficult to see sometimes, so let's just try a few. We could do this. Oops, no, we couldn't. We'd have to do this rather, so go visit C and head there. So then we just add up the edges that we cross, so we've got a 10, 13, another 10, and an 8, so 18, 28, 31, 41. Well, who knows if that's meters or kilometers? We'll say kilometers. It's a long walk. Anyway, so let's try some other ones. We could do this. What could we do? Go down here, come up, and that's another one, so 12 plus 10 plus 10, what, 27, 37, 39 I'm getting for that one. We could also do this. Head down this one, and then round the back like that. That would be 12 plus 13 plus 7 plus 8, 25, 35, 38, is that right? 15, 25, 28, 40 I'm getting for that. Okay, so of all these, the shortest route I got was 39, which was home to B to C to D and back home again. 39 kilometers. But of course, I've got no proof that that is the shortest one, and you might be able to find a shorter way through this and decide that that's a more optimal way to go. Anyway, go ahead and access the questions in the description for the video.